A few months ago, scientists warned that Southern California's San Andreas Fault is gearing up for a major earthquake, the first in over 160 years. New NASA data reveal alarming changes deep beneath the surface, hinting that a massive seismic event might be closer than anyone expected. What exactly is happening along this notorious fault line, and how soon could it strike? Let's explore. NASA's advanced Earth observing systems have provided groundbreaking data on tectonic plate movements with unprecedented precision. Over the past year, anomalies detected along the southern stretch of the San Andreas Fault have shown an increase in ground deformation that challenges previous models. Large surface cracks are now visible from space. These aren't minor fractures like those caused by small tremors, but pronounced, interconnected fissures that are growing larger and more connected over time, forming a visible network of stress indicators that scientists describe as significant signs of geological strain. What's particularly noteworthy is that NASA's high-resolution satellite imaging has identified these cracks in areas once considered stable. The Salton Sea region, which has a history of seismic activity, now shows new surface ruptures and measurable ground displacement that appears to be increasing. The fault zone is experiencing a process called fault creep, where the land shifts gradually without triggering immediate earthquakes. While this might seem like a slow release of energy, it signals complex stress patterns along the fault. Some segments are moving subtly, while neighboring sections may be locked in accumulating pressure, which could influence future seismic activity. Have you ever wondered what it means when the Earth starts shifting gradually without immediate earthquakes? Could this be a ticking time bomb? Comment and chat with me. What makes NASA's discoveries particularly noteworthy is the convergence of multiple geological indicators pointing toward significant activity beneath the surface. The satellite imagery shows not just isolated cracks, but an expanding network of interconnected fractures that reflect substantial tectonic forces at work. NASA's advanced INSAR technology, interferometric synthetic aperture radar, has produced detailed three-dimensional models of crustal movements, revealing important ground displacement patterns. These shifts are measured in centimeters over hundreds of square miles, indicating meaningful strain along the fault. Significantly, scientists can now identify where the Earth is bulging and compressing, with patterns similar to those observed before historic large earthquakes. Areas such as the Carrizo Plain and Coachella Valley exhibit displacement signatures comparable to precursory activity seen before major ruptures in other tectonic zones. The potential impact is considerable. When a fault system of this size releases its energy, seismic waves could travel across extensive distances in a matter of seconds, potentially affecting metropolitan areas throughout California within minutes. Additionally, thermal imaging from NASA has detected localized increases in subsurface temperatures near fault intersections, which may indicate increased friction along locked fault zones. This localized heating could contribute to weakening rock structures, possibly influencing the timing and nature of fault movement. But the San Andreas Fault isn't acting alone. Could this unrest trigger a chain reaction along neighboring faults? The San Andreas Fault doesn't exist in isolation, and this is where the situation becomes truly nightmarish. NASA's comprehensive imaging has revealed that movement along the main fault is beginning to influence activity in nearby fault systems, including the San Jacinto and Elsinore faults. This creates the potential for what seismologists call a domino effect, where stress released in one fault triggers cascading failures in others. Computer simulations based on NASA's real-time data show scenarios that would have seemed like science fiction just a few years ago. Multi-segment ruptures that could produce earthquakes of magnitudes far higher than anything California has experienced in recorded history. We're talking about the possibility of a magnitude 8.0 or even higher earthquake. An earthquake so powerful it would fundamentally reshape the geography of Southern California. The interconnected nature of these fault systems means that a rupture starting at one end could propagate like a zipper opening, unlocking segment after segment in a chain reaction of destruction. The energy release would be equivalent to hundreds of nuclear weapons detonating simultaneously beneath some of America's most populated cities. Recent discoveries have also revealed previously unknown fault splays, secondary fracture zones that run parallel to the main San Andreas trace. Many of these hidden structures lie directly beneath populated areas that were never considered to be at high risk. Cities and towns built over these concealed fault lines could face even more severe shaking than previously calculated, as seismic energy gets redirected and amplified by these underground fractures. Before continuing, I have a special 10-second request for all of you listening. If you can help me in any way, please hit the notification bell and subscribe. It helps this channel so much. And if you do that, I will do everything I can to make this show even better for you. Deal? Using predictive models powered by artificial intelligence and machine learning algorithms, NASA scientists have created the most detailed rupture scenarios ever developed. These simulations incorporate everything from soil composition and fault geometry to historical earthquake data, generating terrifyingly realistic visualizations of what could happen when the fault finally gives way. The models show that if the southern segment ruptures, the energy could travel northward at speeds of up to 2 miles per second, striking major urban centers with virtually no warning time. The simulations incorporate the unique geological characteristics of Southern California, including the soft sedimentary basins that underlie cities like Los Angeles and Riverside. And there's another piece of the puzzle. Could California's changing climate be pushing these faults closer to a breaking point? What makes this situation even more complex and dangerous is how environmental factors are accelerating the timeline toward disaster. NASA's long-term monitoring has revealed disturbing correlations between climate patterns and seismic activity that nobody saw coming. Changes in groundwater levels, driven by California's extreme weather cycles of drought and flooding, are directly influencing fault stability in ways that could trigger the catastrophic event we're all dreading. Here's the terrifying reality. When water seeps into deep rock layers during heavy rainfall periods, it acts as a lubricant, reducing friction along fault surfaces. NASA's gravitational measurements have detected significant changes in subsurface fluid pressure throughout the fault zone, and the data show a direct correlation between these pressure changes and increased microseismic activity. Essentially, California's unpredictable weather patterns are playing Russian roulette with one of the world's most dangerous fault systems. The implications are staggering when you consider California's recent climate extremes. The state has experienced everything from record-breaking droughts to atmospheric river events that dump unprecedented amounts of water in short periods. Each of these extreme weather events creates subsurface pressure changes that could be the final trigger needed to unleash centuries of stored tectonic energy. NASA's collaboration with the United States Geological Survey has produced the most comprehensive fault monitoring system ever deployed. The fusion of space-based observations with ground-based sensors has created a real-time picture of fault dynamics that's both fascinating and terrifying. The cracks identified by NASA's satellites have been confirmed through aerial surveys and ground inspections, where geologists have recorded fresh scarps, displaced rock formations, and infrastructure that's being torn apart by the moving Earth. But here's what's keeping scientists awake at night. The rate of change is accelerating. Measurements that used to change over the years are now changing over months. Ground displacement that was once measured in millimeters per year is now being recorded in centimeters per month in some areas. The Earth isn't just preparing for a major earthquake, it's racing toward one. The human cost of what's coming is almost impossible to comprehend. Southern California is home to over 24 million people, many of whom live within 50 miles of the San Andreas Fault. When you factor in the region's infrastructure, from the sprawling freeway networks to the complex web of utilities that keep the region functioning, the potential for catastrophic failure becomes clear. NASA's detailed mapping has identified critical infrastructure that crosses the fault zone at multiple points. Major highways, railway lines, airports, and shipping ports all lie directly in the path of potential ground rupture. The economic implications alone are staggering. We're looking at potential damages that could exceed $300 billion, making it the costliest natural disaster in American history. But the economic impact pales in comparison to the human tragedy that could unfold. Emergency services would face challenges unlike anything they've ever encountered. Communication systems could be severed for days or weeks, as cell towers and fiber optic cables cross the fault zone in hundreds of locations. The ability to coordinate rescue operations would be severely compromised just when it's needed most. Water systems present another nightmare scenario. The California Aqueduct, which supplies water to millions of people, crosses the San Andreas Fault at several points. A major rupture could cut off water supplies to vast areas of Southern California for months, creating a humanitarian crisis of unprecedented proportions. NASA's models show how ground rupture could damage or destroy water treatment facilities, leaving entire metropolitan areas without access to clean drinking water. The psychological impact cannot be ignored either. For decades, Californians have lived with the knowledge that the big one was coming eventually. But NASA's revelations have transformed that abstract future threat into a tangible, immediate danger. Real estate markets in fault-adjacent areas are already showing signs of instability as the reality of the situation becomes clear to residents and investors. As we consider the vast consequences, the question remains, how visible and immediate is this threat? What makes this situation uniquely terrifying is how the abstract concept of earthquake risk has suddenly become visible and measurable. The cracks that NASA has identified aren't theoretical models or computer simulations. They're real, physical manifestations of the enormous forces building beneath California's surface, and they're growing larger every day. There's a psychological dimension to this crisis that's equally disturbing as the geological evidence. With each discovery, the public perception of safety in Southern California is fundamentally shifting. For generations, Californians have lived with the abstract knowledge that a major earthquake was inevitable. But NASA's findings have transformed that distant threat into an immediate, visible reality. The term "the big one" has been part of California's vocabulary for decades, evoking a mixture of anxiety and resigned acceptance. But now, as technological advances allow us to peer beneath the Earth's surface with unprecedented clarity, that abstract specter has taken on a tangible form. The San Andreas Fault is no longer just a line on a geological map. It's a living, breathing system of fractures that's visibly preparing for catastrophic failure. This shift from theoretical to observable has profound psychological implications. Real estate agents report increasing numbers of clients asking detailed questions about fault proximity that never came up in conversations just a year ago. Insurance companies are quietly revising their risk assessments, and some are beginning to limit coverage in areas that NASA's data has identified as particularly vulnerable. The visible cracks serve as constant reminders of the forces at work beneath people's feet. Unlike other natural disasters that strike without warning, this geological time bomb is announcing its presence through increasingly obvious surface manifestations. It's as if the Earth itself is sending warning signals that are impossible to ignore. What do you think is the biggest challenge facing California if a major quake strikes soon? Drop your thoughts in the comments. Beyond public perception, NASA's findings offer a rare glimpse into Earth's hidden conversations. What exactly is the planet trying to tell us? NASA's revelations represent more than just scientific advancement. They provide a rare glimpse into the planet's most fundamental processes, offering both empirical data and a sobering reminder of Earth's dynamic character. The crack along the San Andreas Fault is essentially a whisper from the planet's depths, a hint that something vast and unstoppable is preparing to unfold. What makes these findings particularly significant is how they challenge our understanding of earthquake prediction. While scientists have long maintained that precise earthquake forecasting is impossible, NASA's comprehensive monitoring is revealing patterns and precursory signals that were previously undetectable. The combination of surface deformation, thermal anomalies, electromagnetic signals, and fluid migration patterns is creating a multi-dimensional picture of fault behavior that's unprecedented in seismological research. The implications extend far beyond California's borders. The techniques and technologies NASA has developed for monitoring the San Andreas Fault are being applied to other major fault systems around the world. From the New Madrid seismic zone in the central United States to the North Anatolian Fault in Turkey, scientists are discovering similar patterns of stress accumulation and precursory activity. The sophistication of NASA's monitoring systems has revealed phenomena that sound like science fiction but represent cutting-edge earthquake research. Satellite observations have identified patterns of anomalous electromagnetic signals in areas adjacent to the fault, subtle electrical charges generated by stress in crystalline rocks through the piezoelectric effect. These signals, though barely detectable, often appear before significant seismic events in other parts of the world. Even more intriguing is the discovery of deep fluid migration patterns beneath the fault zone. Using gravitational measurements and remote sensing techniques, NASA has begun mapping how water, carbon dioxide, and other fluids move through the fractured rock deep underground. These fluids play a crucial role in fault mechanics, sometimes acting as lubricants that can trigger sudden slip events. The southern section of the San Andreas appears to be undergoing significant changes in fluid pressure, influenced by both natural processes and human activities like groundwater extraction. As underground aquifers are depleted, the reduced pressure can destabilize fault segments that have remained locked for centuries. It's a sobering reminder of how human activities can inadvertently influence geological processes on a massive scale. Subscribe now for the latest on earthquake science and warnings. Stay informed so you and your loved ones are prepared before the next big event. The technological capabilities that have made these discoveries possible represent a quantum leap in Earth observation science. Satellites equipped with LiDAR systems can now track ground deformation with centimeter-level accuracy across thousands of square miles. By comparing current measurements with historical data, NASA can create time-lapse visualizations of how the Earth's surface is slowly warping and bending as tectonic forces build toward their inevitable release. Multispectral thermal imaging has added another layer of insight, revealing geothermal anomalies that indicate changes in subsurface heat flow and pressure conditions. While the San Andreas Fault isn't volcanic, localized heating from tectonic friction can weaken rock structures and create conditions that favor mechanical failure under stress. With such detailed insight comes a powerful need for cooperation. How are scientists, engineers, and officials joining forces to face this looming threat? The magnitude of this threat has forced unprecedented collaboration between NASA, the USGS, and emergency management agencies across California. Urban planners, civil engineers, and emergency response teams are working together to understand how a major rupture would intersect with the complex infrastructure that millions of people depend on every day. New vulnerability assessments are being developed using NASA's precise fault mapping, identifying buildings, bridges, pipelines, and communication systems that lie directly in the path of potential ground rupture. Engineers can now visualize exactly how seismic waves would propagate through specific neighborhoods, accounting for soil composition and geological amplification effects that could make the shaking even more destructive. The agricultural implications are equally staggering. The San Andreas Fault intersects some of California's most productive farming regions, areas that supply food to the entire nation. NASA's satellite imagery has revealed how intensive groundwater pumping for irrigation has caused significant land subsidence, potentially altering the mechanical balance of surface layers and contributing to fault instability. Perhaps the most remarkable development emerging from NASA's research is the creation of digital twins of critical geological regions. These virtual Earth models integrate every known variable, from topography and soil composition to strain rates and hydrology, allowing researchers to conduct scenario testing on an unprecedented scale. These digital simulations can answer questions that were previously impossible to address. What would happen if a major rupture occurred during peak traffic hours? How would aftershocks affect water reservoirs in mountainous areas? How would stress redistribution impact other fault systems hundreds of miles away? The answers aren't theoretical anymore, they're calculated with scientific precision, offering decision-makers crucial insights into possible futures. So what does all this mean for California, and for all of us watching? The answers are still unfolding, but the time to prepare is now. NASA's recent discoveries have significantly deepened our understanding of seismic risk in California. What was once an abstract geological concept now presents visible, measurable signs of an active and dynamic Earth beneath the San Andreas Fault. The cracks seen along the fault are more than surface features. They are indicators of long-term geological processes involving stored energy that has been accumulating for more than 3 centuries. Although the exact timing remains uncertain, the scientific evidence points to Southern California facing a substantial seismic risk. Advanced satellite monitoring, artificial intelligence modeling, and collaborative research are providing unprecedented insight into these underlying forces. The key question is not if a major earthquake will occur on the San Andreas Fault, but when. Based on the data from NASA's research, the time frame could be sooner than previously expected. Preparation is essential now, while there is still an opportunity to respond to these warning signs detected beneath the surface. What are your thoughts on these findings? Have you noticed any unusual seismic activity in your area? Share your experiences in the comments, and be sure to subscribe for updates on this evolving story. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.